Hi again. Now we're going to discuss on active high pass filter. So this is the circuit for active high pass filter. Notice now the difference between active low pass filter and active high pass filter is that the location of the capacitor here. For the active high pass filter, the capacitor is at the input side. We still have R1 input resistance, and we also have input resistance feedback. Okay, as for the derivation, again we're going to consider the same, where we have I1 plus I2 equal to 0 at this summation point. At the input side, we have I1 that we go through on both capacitor and resistance. So we need to define what is I1. In order to define I1, we can solve it using this equation, where we know that the total voltage input is actually sum of voltage in capacitor plus voltage in resistor. So we're replacing this is VC and this is VR. So we'll be able to solve for I1. This is the equation for I1, and this is the equation for I2. So using I1 plus I2 equal to 0. This is I1 plus I2 equal to 0. Then we'll be able to solve for V out here. So again, we replace S with J omega. All the term S is replacing with J omega. Then we'll be able to find the magnitude of gain. So this is the first equation, where this is the gain at any frequency. Okay, at any frequency. Then we also able to find the magnitude of gain in frequency ratio form. So, this is the second equation in radian per second, and this is the third equation in hertz. As a summary, this is the circuit for high pass active filter, where you should be able to draw this circuit where we employ operational amplifier. Then the transfer function, we have three equations that we have already derived. The first one is in terms of any frequency, second one in terms of frequency ratio form in radian per second, and the third one is in terms of frequency ratio in hertz. So you'll be able to calculate the cutoff frequency using 1 over RC1 or 1 over 2 pi R1 C1. Again, same as low pass filter, we have two parts. The first part is for the amplification part, where RF over R1 define the overall filter gain. And the second part here, we define the filtering effect. So again, the response for the high pass filter, active high pass filter. So the gain here, we depend on the value of RF over R1. If you choose RF over R1 equal to 2, then the gain here will become 2. As at the frequency ratio, as at the cutoff frequency, the value here is actually RF over R1 multiply with 0.707. Why 0.707? Because when there is no gain equal to 1, it will give value 0.707. But if you design the circuit to be another value, 3, 10, or other gain value, then you must multiply with 0.707. Let's continue with band pass filter. So this is the circuit for band pass filter. If we look at this circuit, we can see that it is actually a combination of low pass filter and high pass filter. So if you notice, by closing C1 here, if you cancel C1 here, then it is actually a low pass filter. But if we cancelling CF here, then it is a high pass filter. So the band pass filter is actually a combination of low pass filter and high pass filter. To derive the equation for band pass filter, we're still considering I1 plus I2 equal to 0, or I1 equal to minus I2, where I1 is the current at the input part and I2 is the current at the feedback part. So we can see a combination of C1R1 in I1 here and RF-CF in I2 here. So replacing I1 and I2 into the equation, we finally get the equation for V out is this equation. So if you notice in this equation, it is actually a combination of low pass filter, high pass filter, and gain part. So this is the gain part. 1 over R1C1S over 1 plus R1C1S is high pass filter, and 1 over 1 plus CFRFS is low pass filter. In form of frequency, the gain is written in form of omega here, and in band pass filter, we're going to have two cutoff frequency. The first one is FC1, which is 1 over 2 pi R1C1, which is actually the cutoff frequency for high pass filter. And the second cutoff frequency is 1 over 2 pi RF-CF. That is actually a cutoff frequency for low pass filter. In terms of frequency ratio form, this is the equation that considering F over FC1, F over FC1 for the high pass part, and F over FC2 for the low pass part. As for the overall gain, it is the gain that defines the gain when the frequency is between cutoff frequency 1 and cutoff frequency 2, which is RF over R1. Lastly, this is the response for band pass filter, where we can see here when omega is between omega C1 and omega C2, the gain is actually at the overall filter gain, RF over R1. And we have two cutoff frequency, FC1 and FC2, and it will determine the bandwidth for the band pass filter. FC1 is actually a cutoff frequency for high pass filter, and FC2 is the cutoff frequency for low pass filter. At both cutoff frequency, the value will be equivalent to RF over R1 multiplied with 0.707. Okay, so if you design RF to be 5, then you need to multiply 5 with 0.707. Lastly, if you notice in this response graph, it is actually a combination of response for high pass filter for this side. Okay, for this side, it is similar to high pass filter response. And if we consider for this side, it is actually the response for low pass filter part. So for simplification, we can just consider the equation for high pass filter in order to determine the gain. Okay, because we see the high pass filter response first, then only we see the low pass response filter second. Then we only consider FC2, which is the cutoff frequency for low pass filter, if we want to determine the bandwidth. So that in this way, we will simplify the equation. Just consider the equation for high pass filter together with gain and part. Then it will simplify the equation because it will give you the same gain and the same frequency. Just need to determine the bandwidth using the low pass filter, which is FC2. So that is the end for lecture on topic filter. We have discussed on two types of filter. The first one is a simple RC filter, which include simple RC low pass filter and simple RC high pass filter. Then we also consider active filter, where we discuss on three types, which is low pass filter, active low pass filter, active high pass filter, and active band pass filter. If you notice in my explanation, I use sometimes I use omega, or sometimes I use frequency. It is actually the same whether to use omega or use frequency F, because it's just a matter of unit, omega in radian per second, frequency in hertz. So it is the same value. So I hope that you will not confuse when seeing the explanation between sometimes I use omega and sometimes I use frequency. Okay, that's all, and thank you.